In this video, we are going to see about the solution for linear differential equation of second order. The linear differential equation of nth order with constant coefficients is in the form of C naught dn power y dx power n plus C1 dn power n minus 1 by dx power n minus 1 into y plus etc. plus Cn minus 1 into dy by dx plus Cny equal to f of x, where C0, C1, etc. Cn are constants. The general solution or the complete solution for the second linear differential equation consists of two components. One is the complementary function and second one is the particular integral. Then the solution can be written as y equal to Cf plus Pi. Now consider the second order differential equation of the form C0 d squared y by dx square plus C1 dy by dx plus C2y equal to f of x. This equation can also be written as C0 d squared plus C1 d plus C2 into y equal to f of x. So let us consider this equation as equation number 1. Here this capital D denotes d by dx. Now first we are going to find the complementary function for the given equation 1. So for this we have to find the auxiliary equation. Then the auxiliary equation is given by replacing d by m in the above equation 1. So the left hand side of the term will become C0 m squared plus C1 m plus C2 equal to 0. This is a quadratic equation in m. Solving this equation, we get two values for m. So let us consider those values as m1 as well as m2. So the nature of the roots, we can write the complementary function. So totally we are having three types. So if the roots are real and distinct, that is m1 not equal to m2, then the complementary function is a e power m1x plus b e power m2x. If both the roots are repeated roots, that is m1 equal to m, then that root is taken as m. Then the complementary function is ax plus b into e power mx. If the given root m is in the form of a complex number, then the real part is denoted as alpha and the imaginary part is denoted as beta. Then the complementary function is e power alpha x into a cos beta x plus b sin beta x. Now next we are going to find the particular integral pi. So here we consider four types of particular integral based on the terms given in the right hand side in the above equation number 1, that is f of x. So in type 1, if f of x, that is our RHS term, is in exponential form, that is in e power ax, then replacing d by a, we get particular integral. Type 2, if f of x is either cos ax or sin ax, then replace d squared by minus a squared. Then the remaining d term we multiply and divide by their conjugate. Again we get d squared in the denominator. So once again we repeat the same procedure. So in type 3, if the f of x is in the form of x power n, then using the expression either 1 plus x the whole power minus 1 or 1 minus x the whole power minus 1, we can find the value for particular integral. In type 4, if our f of x is e power ax into x power n or e power ax into cos ax or e power ax into sin ax, then in this type we are having two steps. In step 1, just first replacing d by d plus a. Then we consider we are having only the term either x power n or cos ax or sin ax. Then we can use either type 2 or type 3 for finding particular integral. Now let us see one example for solving second order differential equation. Now solve d square plus 5d plus 4 into y equal to e power minus x into sin 2x. So in this case we are having only one term in the right hand side, that is our f of x. Hence, the solution is y equal to CF plus PI. Now, first let us find our complementary function. So, for finding complementary function, let us choose the auxiliary equation. So, replacing d by m, so we get m squared plus 5m plus 4 equal to 0. So factorizing, we get m plus 4 into m plus 1 equal to 0. So either m plus 4 equal to 0 and m plus 1 equal to 0. So we get two values for m. One is m equal to minus 4, another one is m equal to minus 1. So here these m two roots are real as well as distinct. So m1 not equal to m2. So by case 1, our complementary function is a e power m1x plus b e power m2x. Therefore, our required CF equal to a e power minus x plus b e power minus 4x. Consider this as equation number 1. Next, we are going to find the particular integral. So, particular integral equal to 1 by our f of d, that is d squared plus 5d plus 4 into our f of x e power minus x into sine 2x. So, in this case, we are using our type 4, that is e power ax into sine ax. So, just replacing d by d plus a is our first step. Here, we replacing d by d minus 1 since a equal to minus 1. So, now we bring this e power minus x to the front. So, e power minus x into 1 by d minus 1 the whole squared plus 5 into d minus 1 plus 4 into sine 2x. That is e power minus x into 1 by, now using a minus b the whole square formula, we get 2d square minus 2d plus 1. Multiply this 5 into inside, we get 5d minus 5 plus 4. Simplifying, we get e power minus x into 1 by d square plus 3d into sine 2x. Now using our type 2, that is our trigonometric form. So replacing, put d squared equal to minus a squared. So here a equal to 2. So replacing d squared equal to minus 2 squared, that is minus 4. Therefore pi equal to e power minus x into 1 by minus 4 plus 3d into sine 2x. So again we get 1d in the denominator. So multiply the conjugate minus 4 minus 3d and multiply and divide. We get e power minus x into 1 by minus 4 plus 3d into minus 4 minus 3d by minus 4 minus 3d into sine 2x. Therefore, e power minus 4x into, so multiply the numerator 1 into minus 4 minus 3d as minus 4 minus 3d. Here using a plus b into a minus b. So we get a squared minus b squared, that is minus 4 the whole square. So 16 minus 9d squared. So again substituting d squared equal to minus a squared, that is minus 4. We get minus 4 minus 3d divided by 16 minus 9 into minus 4. So the 16 plus 36 we get. So multiply the sine 2x into the numerator term. So we get minus 4 sine 2x minus 3d sine 2x. So differentiating, we get sine 2x, d sine 2x is 2 into cos 2x. So our required particular integral is e power minus x into minus 4 sine 2x minus 6 cos 2x divided by 56. Now substituting this equation number 1 and equation number 2 in our solution A, we get y equal to CF plus PI. That is y equal to a e power minus x plus b e power minus 4x plus e power minus x into minus 4 sine 2x minus 6 cos 2x divided by 52.